Here, this is Edexcel Mechanics 1 October 2016 question. Question number 1. The question is about collision and momentum. Here we have two particles P and Q have masses 2m and 3m respectively. So particle P, which has mass 2m, another particle Q which has mass 3m. They are moving towards each other in opposite directions. So P is moving this way and Q is moving this way along the same straight line on a smooth horizontal plane. So they are in straight line movement. They are not experiencing any friction. Then the particles collide. Immediately before they collide, the speed of P is 2u. So P was moving this way with velocity or speed 2u, and Q is moving with velocity u. The speed of Q is u. In the collision, the magnitude of the impulse exerted on P by Q is 5 mu. So the impulse means change in momentum of P due to Q is 5 mu. That means Q was moving this way, P is moving this way. So the impact on P from Q is acting in this way, which is 5 mu. This is the change in momentum of P. Equal change in momentum can happen to Q in the opposite direction. 5 mu. This is the change in momentum of Q due to P. This is change in momentum of P due to Q. Okay. The questions: find the speed of P immediately after the collision. So after the collision, P has tendency to move in the opposite direction along this change in momentum that I named it as Vp, and Q has tendency to move this way. We can name it as Vq. This is the velocities of P and Q after collision. In the first question, we need to find Vp after collision. And this third question, we need to find that of Q after the collision. So this is the first question. This is the third question. Okay, we can solve it. How? We can use the concept of impulse or change in momentum. We know change in momentum is equal to final momentum minus initial momentum. But change in momentum for P, we can do the first question first. Change in momentum of P is 5 mu is equal to final momentum of P is its mass is 2m and its final velocity is Vp, that is we need to find, minus initial momentum of P, its mass times its initial velocity was in this direction, which is opposite to the direction of Vp. We took here this direction as positive for this P, so opposite direction is negative, so it is minus 2u. Okay, so we can rearrange the equation as 5 mu is equal to 2m is common into Vp minus 2u. So m and m will cancel. This become 5u is equal to 2 times Vp minus become plus 2u. That is 5u is equal to 2vp plus 2 times 2 4u. Taking this to the other side, 5u minus 4u is equal to 2vp, or 5 minus 4 is 1, so 1u, that is u, is equal to 2vp. Or from here we can write vp is equal to u divided by 2. This is the answer for the first question. Okay, then in the second question, B part, they're asking, state whether the direction of motion of P has been reversed by the collision. Yes, that is reversed, that we know. So it is one more question, so we can just write the answer as it is reversed. It should reverse because the impact is acting in the opposite direction of movement, so it should change the direction, and the change in momentum has enough value to change the direction. And the concept of third law of momentum, third law of motion, also gives the concepts. We are not going to discuss that thing, so we can solve the next part. Find the speed of Q immediately after the collision. So the third part is to find the speed of Q. Same concept we can use for Q also. The change in momentum is 5 mu this way. So its change in momentum 5 mu is equal to, so here I am going to take this direction as positive for Q, opposite thing is negative. So 5 mu is equal to, its final momentum is its mass multiplied with its final velocity Vq, that is we need to find, minus its initial momentum is its mass multiplied with its initial velocity was in the opposite direction of these things, so minus u. So we can rewrite it as 5 mu is equal to, 3m is common, 3m, and vq minus u. So that become is equal to, this m and m we can cancel, this we can write it as 3 times vq plus u. So we can write 5u is equal to 3vq plus 3u, or 5u minus 3u is equal to 3vq, or from here we can write 5 minus 3 is 2, 2u is equal to 3vq. So vq is equal to 2 divided by 3u. This is the final answer for velocity of Q after collision. Okay, thank you for watching.